Today we're going to be talking about factoring the greatest common factor. Greatest common factor is also known as the GCF. And so our first example is, how do you really do that with just numbers? And so let's take the number 6 and the number 15. Okay? If we're looking for the greatest common factor, we're looking for the number that will multiply to give me 6 and also multiply to give me 15. That would be the biggest number that they both have. So if you look at 6, we should know that 2 times 3 is 6 and 1 times 6 is 6. And we're looking for one of those numbers we just said that will give us 15 as well. Well, the factors of 15 are 1 and 15 and 3 and 5. And they both have a 1 in common, but they also both have a 3 in common. And this becomes our greatest common factor. So 3 is the GCF. Okay? So you try it. Let's do 24 and 18. You need to pause the video and then come back and check your answer. So the numbers that give us 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 doesn't work, and then we're back to 6, so we can stop choosing factors. The ones that give us 18 are 1 and 18, 2 and 9, 3 and 6. 4 doesn't go into 18, 5 doesn't go into 18, and 6, there it is. So those are all the factors. So now if we look, they both have a 1, they both have a 3, they both have a 2, and they both have a 6. So what's the biggest number that they both have? 6. So 6 would be our greatest common factor. Let's now look at an example where we have variables involved. Now I chose to use the same numbers as before, the 6 and the 15, so you'd see that you would do the same thing no matter what. So what is the biggest number that will multiply to give me a 6 and multiply to give me a 15? Well, we said before that that was a 3. So our GCF will contain the number 3. So how do you do the letters? Well, it's very, very simple. You look and you say, what's the greatest number that they both had? Think about it this way. If you were dealing with money, let's say you were this X here, and you had $13, and your friend had $10, and y'all both had to pay the most amount that you could pay, but it had to be the same that both people paid. For example, you would both have to pay $5 or something like that. So you have $13, your friend only has 10. What's the most that y'all both can pay that's the same? $10, right? Because your friend can't pay more than 10, and you have $10 inside of your $13. So the greatest common factor for the letters would be, for the X, would be 10. And also another way to think about it is, what's the smallest exponent of that letter? That's going to be your greatest common factor for that letter. So let's look at the Y's. Well, we look here, we have an 8, and we have an understood 1. So what is the lowest that they have? 1. And so this becomes your greatest common factor. Again, if you're thinking about it in terms of money, you have $1, your friend has 8. What's the most that y'all both can pay that's exactly the same? 1, because you only have 1. Okay? So now let's try an example where you do it on your own. Okay, given this example, find the greatest common factor. You can pause the video to work it out by yourself, and then unpause it to see if you've got the correct answer. So the greatest common factor between 10 and 8 is 2. If you look at the x's, they do both have an x, so you have to write an x. Now, what's the smallest exponent of x? It's 2. Okay? They both have a y, so you have to write a y. And then what's the smallest exponent of the y? The 3. And so this becomes your greatest common factor. Now let's talk about how to factor polynomials with the greatest common factor. Okay? So this is a binomial, and for all binomials, you're going to want to try to factor with the GCF every time before you do anything else. Okay? So if we look at this, we're going to treat it just like we did the previous questions, where we're going to look at these two terms and we're going to figure out what's the greatest common factor. So what number will go into both 3 and 9? It's 3. Then we're going to look at the letters. They both have an x, so we'll write the x. What is the smallest exponent? It's 2. So I'm going to write the 2 on the outside. Okay? And now we're going to write a parentheses, because we have to take this greatest common factor out by dividing it. Now, when you divide the numbers, it's just like you would normally divide. And when you divide the letters, it's really you're just subtracting the exponents. So when I refer to it, I'm just going to say subtract the exponents. Okay? Or take out 2, which means subtract 2 from what we have. So 3 divided by 3 is 1. Okay? And then you have 4 x's, and we took out 2 or take away 2, and so we have 2 left. Now we don't need this 1 in the front, so I'm going to erase it. And then we're going to look. We have positive 9 divided by positive 3. That gives us a positive 3. I have 2 x's, and I take away 2 x's, so I have no x's to write. And this is what our factored form will look like. Okay? But then you can always go back and double check to see what your answer will be by trying to multiply it back out. What's 3x squared times x squared? Well, 3 times 1 gives you 3. And x squared times x squared, when you multiply, you add the exponent, so you get x to the 4th. That checks. 3 times positive 3 is positive 9. And then there's an x squared, and that's all we have. And see how it goes back and it checks out? So you know you're doing it right because you can double check. Okay? Let's try the next example. Okay? You can pause the video, work on it, and see if you have the right answer by playing the video again. So when you look, you're first going to always try to see if there's a GCF. Yes, this is a trinomial, but you always want to look for a GCF first when you're factoring anything. Doesn't matter what method you're going to use. Okay? So, what goes into 15, 5, and 25? You got to check all 3 of them, not just 2. And if you look, they all end in a 5, so 5 must be the greatest common factor. Okay? So you pull out a 5. Do they all have an x? No, they don't. Okay? So you can't pull out an x. Yes, this one has an x, and this one has an x, but this one does not. They all don't have it in common, so you cannot pull it out. Okay? And so you write a parentheses after you've written your greatest common factor. What is 15 divided by 5? It's 3. And then we didn't take any x's away, so you have all the x's that you started with. Negative 5 divided by 5 is negative 1. And then you have x squared. We didn't take anything away, and so now we don't need the 1. We can just leave it as x squared. Okay? Positive 25 divided by 5 is positive 5. And it didn't have an x, so we don't have any x's to write here. And that becomes your final answer. Okay, let's look at this final example that we're going to do. I tried to make it as hard as possible. Okay? So, Take a moment, try to figure it out yourself, and then pause it, and then you can play it again to see if you've got the right answer. First thing you want to do is look and see what the GCF of the numbers would be. We have 24, we have 12, 36, and 2. Since 2 is the smallest number, that's the one you're going to want to base everything off of. So, will 2 go into everything? Yes, it will. So 2 would end up being my GCF. Okay? So now let's look at the letters. Do they all have an X? Yes, they do. So now we look through and see what's the smallest exponent of X. And 3 is the smallest one. So then 3 becomes my exponent of my GCF. Now we look, do they all have a Y? No, they don't. This one does not have a Y. So you cannot pull out a Y because they don't all have a Y. And then notice how this one has a Z. Do any of these have a Z? No, they don't. So we can't pull out a Z either. Okay? So now we draw our parentheses because this is our GCF. 24 divided by 2 is 12. We had 3 X's here, and we pulled 3 out, so we don't have any X's to write. We have 4 Y's, and we didn't take any away, so we still have 4 Y's. Negative 12 divided by 2 is negative 6. We have 7 X's here, and we took away 3, so that means we have 4 left. We have 10 Y's. We didn't take any Y's out, so we still have 10 Y's. Negative 36 divided by 2 is negative 18. 9 X's, take away 3 X's, is 6. We have 1 Y. We didn't take any Y's away, so we still have that 1 Y. We have positive 2 divided by 2, which is positive 1. And I'm going to tell you right away, we don't need a 1 because we're going to have something left. We have 4 X's, and we took away 3, so we have 1 left. We don't need to write that 1 either. We have a Z, and we definitely didn't take out a Z, so we have a Z left. And this becomes your factored form of this polynomial. Thank you for watching the Greatest Common Factors video. Move on to factoring trinomials.